Hello, I'm Apura Tanpure with my group Shubham Somasa and Akansha Tanpure. The topic of our presentation is closed loop inverter control using vector control under the guidance of Dr. G. Vijay Kumar sir. Closed loop inverter control using vector control is a modern technique used to run AC motor with high performance. In this method, the inverter supply the motor and the sensor continuously, motor speed and current. The feedback signals are compared with reference value and the controller adjusts the inverter output to maintain accurate speed, torque and flux. Further slide it is explained by Akansha. In this simulation, we use the different components. The power guide is for the making a simulation. Next, DC voltage source is the input to the inverter. Inverter is the device which used to convert the DC supply in three-phase AC supply. Three-phase induction motor to which the supply is given. Next, user SBPWM is a closed loop system for the providing the feedback to the inverter. And last is the scope for the representation of graph which comes from the measuring device like current measurement and voltage. This simulation uses different components. DC voltage source provide the DC bus voltage to the inverter. Inverter convert DC voltage to the three-phase AC voltage to drive the induction motor. SPPWM block generate PWM gate pulse based on to reduce the harmonics and maximize the DC bus utilized. ABC DQ converter three-phase current into DQ axis current. DQ ABC converter convert DQ axis voltage back to three-phase voltage for inverter input. Flux calculation block estimate a rotor flux based on motor parameters and feedback current. Theta calculation blocks generate the electrical angles for a DQ transformer. Reference torque block generate torque reference, torque speed input. Speed reference use defined speed setup for the induction motor. Speed feedback measurement actual rotor speed and sends back to the control loop. Speed error calculation difference between reference speed and actual speed. PI control generate torque producing current from speed error. PI current generate from speed error calculation generate flux producing current. Pulse generator generates gate signals for input switch. Three-phase induction motor converts electrical power into mechanical output, torque and speed. Current measurement blocks measure stator phase current measurement block measure stat phase current output display shows torque, speed, voltage, and current waves numerically and graphically. Power guide defines solve type and sample time for electrical simulation. Torque, speed, and measurement block measurement electromagnetic torque, mechanical speed.
So hello everyone, I am Shubham from outside. So as per Akansha told all about the components. So we will make this all these connections. So first of all, this is a DC voltage source. So let we connect this DC voltage source to the voltmeter. Okay. So this we have to connect for the scope. Next again this terminal to here. This to let me okay. So we have to connect this DC voltage source to this voltage measurement, and this positive terminal to the positive terminal, this negative terminal to the negative terminal. Okay, that's good. Again, this positive terminal to this inverter positive terminal, this negative terminal to this negative terminal. After this, we will join this motor first of all. So simply A to A, B to B, C to C. Okay. So after that, we have to measure this voltage from here also. So again, positive terminal here. Okay. This second voltage measurement and third voltage measurement. Okay. After that, we'll join this voltage measurement to this output voltage. After that, we want to join this negative terminal. So all this negative terminal we have to join here. Okay. B point. After that, this bus selector. These are the bus selectors. Okay. So we have taken here two bus selectors. So join this then or this bus connection. This voltage. Then another V1, V2. So these are all the three phases. So we have to measure this three phases waveform on scope. We have to connect these three phases again. This back to the first scope, then to this. So this is second, first. Again, different scope. We have to join different scope for the per waveform to display the all the waveform clearly. Okay. From this WM to WM, again this subtractor to this WI, and also this WRM to this WI. Again, okay. So all are completed. There remain only this voltage measurement to this positive terminal, this to the negative terminal for the subtractor. And again, from this, we have to join scope to the subtractor again for the WM. So, okay. So here we done all our connections, and this is power guy. So we are going to the run. First of all, just here we have to set the timer 0.04 second. Okay. So this is our simulation, and this is from this scope. You have seen this result. So first of all, we have given this 440 or DC voltage supply. After that, we are using this SPWM technique for the pulse shifting waveform. So here we have seen this waveform in the form of up and down. Thank you.